Hello everyone, welcome back to our Calculus 2 course this semester. Today we're going to start our chapter 7, which is about techniques of integration. So I'm going to introduce you some basic fundamental techniques to do integrals. Okay, there's a lot of techniques, but the purpose is not, the first thing I want to say is there's no guarantee that one technique is going to work for all problems. Okay, so what I'm giving to you is show you the tools, introduce you the techniques, and depends on the problems and depends on the time you spend on practicing, you're gonna decide which technique you're gonna choose to solve the problem. So we're gonna do like one technique at a time, and hopefully by the end of this chapter you're gonna learn quite a number of techniques to solve for integration problem. Okay, and it doesn't mean that whenever you apply the technique you're gonna get the answer right away. The purpose of applying the technique of integration is to simplify the integral, make it look simpler, bring it back to or bring it down to the type of integrals that you've seen before and should be able to solve. So it's going to take time. Okay. We only cover one section today, section 7.1. This section shows you the techniques called integration by part. Integration by parts. The idea is this. Let me start a little bit further, so hopefully everyone gonna follow. Say you have a function f of x. Okay, this is right, f is short, and you take the derivative of the function, and then you integrate it back. It's gonna get you the function f, right, and of course plus a constant c, right. Derivatives, think of it like bring it down one step and then integrate means an antiderivative is going to bring it back up one step. It's going to go back to the function. Example, make sure that you all get it. This is the first thing I want to show you. Integral of the derivative of a function is a function itself. Of course, plus a constant, because when you take the derivative of a constant, you got 0. Example, say I got f of x equal to 3x squared. Okay? Make it easy, then x squared. 3x squared is okay, the same thing, but I don't have to make my life complicated. F of x equals to x squared. So what is f prime of x? It is 2x, right? And the integral of f prime of x, integral of f prime of x, dx, equal to integral of 2x df, which is x squared plus c, which is f of x then plus c, right? See, a constant function. So you integrate the derivative of a function, get it back to your function, of course, plus a constant. That's all I try to emphasize. Okay, that's the first thing. Integral of the derivative, gonna get back to the function. Now, recall one more thing that you guys learned in Calc 1, the product rules. Say I got two functions, let's call it u and v then. U times v, this is a function like f times g, say u times v, okay? Because our book used notation uv, so I use the same. And what if you take the derivative of the product of two functions? And you're going to get what? Derivative of the first times the second function plus derivative of the second function times the first. Okay? This is the product rule that we learned in Calc 1. You have a product of two functions, u, v, u times v, and if you take the derivative of the product, it's going to be equal to the derivative of the first function, which is u prime, times second function, which is v, and then plus the derivative of the second function, which is v, and then times the first function, which is u. Okay. Now, what if I integrate both sides? I apply the integral on both sides. Integral of u times v, derivative going to equal integral of u prime v plus the integral of v prime u. Okay? And this is really the heart of our section today. Look at the left hand side right here. Integral of the derivative. And this is what we show you right here. It's just what? U times v, right? And then equal to, of course, plus a constant, but I still have the integral, so I don't have to write the constant. I will write it later. Integral of u prime v plus the integral of v prime u. Okay? So let me repeat this one more time. I started with the product rule, u times v derivative. I have u prime v plus v prime u. And now if I integrate both sides, on the left hand side, I integrate the derivatives. Go back to our original function, which is u times v. I'm talking about this one right here. And then I integrate the right hand side, I got the sum of two integrals. Integral of u prime v plus integral of v prime u. Okay, and what do we have to do with this? Let's tell you this. Say, if you have an integral, say this one, we want to calculate this integral. Okay? If it's so hard that we cannot calculate it directly, then we can apply this rule right here. This integral could be calculated as what? U times v minus integral of vu prime. Okay? So integral of u v prime, I'll just try to write the derivative on the right and then the original function on the left. But you can write v prime u, is the same thing. Change the markers here. That's gonna be equal to, I subtract integral of u prime v on both sides. I got u times v minus the integral of vu prime. Okay, and this formula right here called the integration by parts. Okay, so integral of uv prime can be calculated at product of uv, no integral. Okay, minus the integral of vu prime. So this is uv prime. This is vu prime. Okay, and this formula called integration by parts. All right, let me give you an example, and I think it's clarify everything. A bunch of examples. Okay, the whole lecture is that, but the best part is examples. It help you to understand the material more. Let's start with the first example. How about this? Calculate the integral of x sine x dx. Oh, by the way, usually for those technical integration by part, you're going to apply if you have like two different types of function in the same integral. So in this one right here, I got two types of function. The polynomial right here, just x, and then the trig function, sine x, right? So I don't know how to do it directly. Then I'm thinking of the technique of integration by parts. So I want to calculate uv prime, right? Integral of uv prime. So I have to do like two subs in here. One is like u and the other is like v prime. Now let me see. If I try to use a red color, then this part is u, this part is like v prime. So let me rewrite it, make it look simpler, or another way of writing it. Integral of u dv, or some book write, our book write this way. Okay, I just rewrite another way. V prime the same thing as dv. If you think about it, equal to u times v subtract integral of v du. U prime is du, derivative of u. Okay, either way, the same. So this part right here, I can think of it as dv or v prime. Oh, it's like v prime, but I feel it's right dv is better. So let me write dv in here. Okay. So if I can calculate u and v and du, then I can apply the formula to solve the problem. So in here, if I let x equal to u and dv equal to sine x dx, then our problem is no more than integral of u dv, right? This integral is no more than integral of u times dv, where u is x and dv is sine x dx. Okay, and I try to figure out u and v so that I can use the formula right here. So x equal to u, and I can calculate du, so dx is equal to du. Let's write the other way. Du equal to dx, even though it's the same. Okay, so u equal to x, so du equal to dx. All right, x equal to u, it's the same thing. All right, u equal to x, so du equal to dx. Derivative both sides. Du means derivative of u. It's derivative x. Okay. If dv equal to sine x dx, oh, v prime is right here. Derivative is sine. So what is v? What v is that derivative equal to sine? Derivative of sine is cosine, derivative of cosine is negative sine, so it's going to be negative cosine of x. You guys see why I got negative right here? Because derivative of cosine is negative sine, with another negative I got sine. All right, so I got u, I got v, I got du. I'm going to apply the formula right here. This one is the integral of x sine x dx, which is 2 part, right? This one is u, this one is dv. It's going to be equal to integral of u times, no integral, equal to u times v minus integral of v du, okay? And I'm going to plug all the numbers in. Our other equation in all the function in u is what? X. And v is negative cosine x, I think. And then subtract the integral. What is v du? V is negative cosine x, and du is dx. We can actually simplify this a little bit more. This is negative x cosine x, so negative cosine, minus with minus become plus, integral of cosine x dx. Okay? We are not done yet, but we are very close. See what happened in here? We started something that seemed impossible to solve, right? We got x and then sine x inside the integral. Integral x times sine x dx. And we don't know how to take care of the problem. But after doing the integration by part technique, do two sub in here, one for u, another one for dv. You can calculate du and v. You apply the formula. You come up with what? This integral going to be equal to u times v, right? Negative x cosine x times plus or minus another integral right here, which is just cosine x dx. And what is so good about this? This is very solvable. So you can do this one, right? So this is negative x cosine x. This is my cosine x. And then integral of cosine is sine x, right? And then plus c. See? You have the answer. We good? Let's try another one. Another example. So the tricky part is, which part should I choose for u and which part should I choose for dv? And the answer is you got to practice, right? And then you're going to choose the right one. If it's not right, then come back and choose again until you get the right one. All right, try another one. Try the integral of x times e to the x dx. Now you guys see that we have two types of functions in this integral again. The polynomial function x right here and the exponential function e to the x right there. Okay? So whenever I have a two-type function, I tend to use the integration by part technique. Hopefully I can simplify and use x right here. If I know I take the derivative, just go down to 1, right, constant, right? So if I think of this one as u, this one is my dv, then I let u equal to x, I let dv is equal to e to the x dx, then my du will be dx. Take the derivative of both sides, derivative of u, so du, derivative of x is dx. And then derivative of v is e to the x, so v is e to the x. Okay? And this one is integral of u dv, right? Integral of x, e to the x dx, this is u times dv. I can apply the integration by part right here, equal to u times v. U times v is x times e to the x. And then subtract the integral of v du. V is e to the x and du is dx. You see? Now this is very solvable. X e to the x minus e to the x plus c, because integral of e to the x is just e to the x. So far, so good? Okay. Now, try one more. So let me just save the answer right here, okay? I'm going to show you one more. This is the integral of x e to the x dx equal to x e to the x minus e to the x plus c. All right? Now, what if you see this integral? Integral of x squared e to the x and dx. So this problem is not just x. They give you an x squared, all right? So again, two type of function. You got polynomial, it's x squared right here, and then an exponential function. Same idea. I'm going to let the first part go to u. U is equal to x squared. And then dv is e to the x dx. Okay? So my u is right here. This is my dv. Alright? And then I have to calculate du. What is du in here? U is x squared, so du is 2x dx. See? Derivative, bring the exponent down, right? So 2x dx. dv is e to the x dx, so v is e to the x. Now I can use the integration by part technique. I have what? Integral of x squared e to the x dx, which is, this is u dv, right? Equal to, this is u dv, equal to u times v. So x squared e to the x, alright, minus v du, so minus what? Integral v du, so e to the x times 2x dx. Okay, this is v du, this is v du, this is u times v, right? Integral u dv equal to uv minus integral v du. I can simplify this a little. This is x squared e to the x minus 2 is a constant. I can bring it outside. Integral of x e to the x dx. So what do we see here? From the integral of x squared e to the x, we bring it down to what? No integral in here. X squared e to the x minus 2 times integral. Just a single x, no more square here. E to the x dx. And now what? We're going to do what? Integration by part one more time. Then we're going to have the answer. Okay? So we never say that if you do integration by part, you got to do it one. We may have to apply the technique a couple more times in here, and you can have the answer. And then you know the integral x e to x dx is equal to this. So this is x squared e to the x minus 2 times of x e to the x minus e to the x plus c in here. Well, you can save the plus c at the end, so you don't have to write plus c inside. Plus c at the end, because c could be constant. So the final answer will be this one. Will be what? X squared e to the x minus 2x e to the x plus 2 e to the x plus c. I distributed negative 2 into the 2 terms, and plus c at the end. This will be the answer. Okay, you may see the similarity out of it. What if you see the question like this? Instead of x squared, we have integral of x cubed e to the x dx. Now, same problem, same type of problem, it's just more complicated because you got x cubed. Integration by part will work. What? U equal to x cubed. dv is e to the x dx. So du is, what did I write? dv right here, right? Okay, I'll write the same way. It doesn't matter. It's the same thing. E to the x df. So du is 3x squared df, and then v is still e to the x. This problem becomes what? U times v, x cubed e to the x minus the integral of v du. So it's going to be 3 is a constant outside, x squared e to the x dx. Okay. And you see, you bring it down from x cubed down to x squared. All right, and how do we take care of this? It's right here. And how do we take care of this? We're going to go back. So in other words, you have this problem, you're going to do integration by part like 3 times. So the next question is there or are there any shorter ways to take care of this type of problem without repeating integration by part many times? The answer is yes. I'll show you a way. You don't see it in our textbook, but I'll bring it to you, hopefully, when you watch the clip. Anyone who watches will get an idea of how to solve the problem, okay? The method is applied. You see in many other books called the tabular method. So let me find a room to write. I need to erase something. Something called tabular method. Okay. We'll go back to our second example. Integral of x squared e to the x dx. Okay, and I'm gonna show you another way to tackle the problem without really doing integration by part 2 times, or we do actually doing integration by part 2 time implicitly. Okay, we're gonna make a table, tabulous, instead of table. Okay, we have derivative, one column, integral, another column. Okay, and of course you're gonna have to choose one part to take derivative. So this part is u, right, for derivative, and this one for integral. So x squared and then e to the x. The little trick here is what? Whenever you want to do derivative, you're going to choose a part that whenever you take derivative, it's going to give you something that's simpler or easier, getting smaller, getting to 0 is the best, right? And for the part of integration, you better choose something that is making like a loop. I choose e to the x because what? Doesn't matter how I do with e to the x, integrated, I still got e to the x. Okay? So, keep taking the derivative for the first column. I got what? 2x. Derivative 2x is 2. Derivative 2 is 0. Of course, I'm not going to do more because 0 keep going 0. Integral of e to the x to e to the x. Integral of e to the x to e to the x. Integral of e to the x to e to the x. And I claim you can stop anytime you like. Okay? You can stop this procedure of taking derivative and integration anytime you like. Okay? Whenever you feel you're good, you stop. And the hint is it. You stop whenever you multiply the two terms together. It has something to easier to integrate. I can stop right here because I can integrate 2 times e to the x. Integral of 2 e to the x dx is doable, right? 2 times e to the x plus c. Or I can stop right here because I see what 0 times e to the x is 0. And integral of 0 dx is c, the constant. I can stop at any time I like, whenever I can integrate. Whenever I see that I can integrate that product, I will stop my derivative and integration calculation. Okay. So the very first part of tabular method is what? First, you choose one term, one function to take derivative, and then the second part for integral. Okay, and keep taking derivative, keep taking integral. All right. Now what? First one is gonna be plus, minus, plus, and then minus. We always start with plus sign and then alternate the sign. The very last part was with the integral. Okay. Draw the arrow down. Arrow down. The last one is this way. Okay. And it's gonna give us how the answer. Watch me. So this integral of x squared e to the x dx is what? Equal to positive x squared e to the x minus 2x e to the x, 2x times e to the x, plus 2 e to the x, see, plus 2 e to the x, minus integral of 0 times e to the x, 0 times e to the x dx, right? And 0 times e to the x is 0. This is the integral of 0 dx, which is c. So the answer is really x squared e to the x minus 2x e to the x plus 2 e to the x minus c, or you can write plus c. Either way. Okay. Similarly, what if my problem is x cubed, right? Now instead of doing integration by part 3 times, we can apply the tabular method. We just make a table, then we can write down the answer from the table quickly. So we start with what? X cubed e to the x. We got what? 3x squared, 6x, 6, and then 0, right? Derivative of x cubed with 3x squared, 3x squared, 6x, 6x, 6, and then 0. E to the x integral is to e to the x. 6x, oh, sorry, e to the x integral again, so e to the x, and then e to the x. Okay. And the rule is what? We start with the plus sign, and then minus, and then plus, and then minus, and then plus. See, I stop right here because I got a 0, right? Okay? What? Plus integral. Okay? This, and last one. So the answer for x cubed e to the x integral is what? X cubed e to the x, x cubed e to the x, minus 3x squared e to the x, okay, plus 6x e to the x minus 6 e to the x. This is e to the x. And plus integral of 0. Integral of 0 is a constant, plus c. Okay, you see? Instead of doing u sub one time, u sub another time, u and v. U sub v sub another time, u sub v sub another time. If you make a table, it's going to look a lot simpler. Okay? Show you one more example using the tabular method. Actually, we've done that a minute ago, a couple minutes ago. This integral. Integral of x, what was that, sine x, I think?